Hi everybody, my name is Abdul Himan, and today my colleagues and I are going to talk about intelligent reflecting surfaces. The outline of this presentation will be as following. We will start with introduction and fundamentals of IRS, and we're going to talk about applications of IRS in wireless communications, and we will mention some limitations. First of all, what is IRS? It's a new technology where you can control the angle of the reflecting signal to direct it to a certain location. We can use the intelligent reflecting surfaces on the building to increase the efficiency of the wireless communication and to get more gain and decrease the interference between the users.
The intelligence reflecting surface, we have 5 important components. We have the 2D surface, reflecting element, and IRS controller, RF transmitter, and user. We will elaborate more on the 2D surface and the reflecting element and the use of the IRS controller. The 2D surface contains a large number of reflecting elements and 3 layers. The first layer contains all the reflecting element component, and the second layer is the copper board, and the third layer is the control circuit board. This control circuit will be used with the IRS controller. All the reflecting element is connected to a tunable chip controller to control the load impedance. The on state will give phase shift equal to 0, and the off state will give phase shift equal to pi. We can use fractor, which is voltage control capacitor. This will allow us to go from 0 to 2 pi phase shift, like the second circuit. And the variable resistor will allow us to change the amplitude of the signal. So the IRS controller will allow us to change both the amplitude and the phase of each reflecting element.
Mathematical model. We have a transmitter and a receiver, and we have intelligent reflecting surface, which consists of meta atoms. And these atoms should be separated by a distance less than the wavelength of the signal. We have a channel from the transmitter to the IRS and a channel from the IRS to the receiver. The channel from the transmitter to the IRS, we call it GN, and the second channel, we call it HN. So when the signal comes and hits the IRS, it will be reflected and phase shifted by an angle theta n. So the signal will be the summation of all atoms of the channels multiplied by the original signal plus the noise. And we have again from the transmitter to the IRS, which is A, the area of the IRS, over 4 pi the distance squared. And the gain from the IRS to the receiver will be A over 4 pi the distance squared. So the end-to-end channel gain, under assumption that we have on line of sight, will be A squared over 4 pi dg all squared.
We will be talking about the system models. First, we have the IRS model, which depends on both passive and active reflections, and the second model, which is the backscatter model, which only depends on passive reflections. First, we will talk about the reconfigurable intelligent surface model. It uses two-dimensional passive reflectors. Therefore, if there isn't a direct line of sight between the transmitter and the receiver, the signal will hit the intelligent reflecting surfaces, causing the IRS to convert the wave and scatter it. The IRS controller can control the phase delay and the polarization of the scattered waves. And as I mentioned before, it depends on both passive and active reflections. Moving on to the second model, the backscatter model, it receives radio frequency signals and converts it into DC voltage. The backscatter model does not generate any radio frequency, but it receives the reflected radio frequency signals, modulates it, and then it communicates using the modulated signal. As shown in the picture, the backscatter model depends only on the passive reflectors?
Applications. We have many applications. One of them is energy focusing, where IRS can be used to direct the reflected signal power to a certain location. Another application is energy nulling, where the signals can be added constructively or destructively to cancel the unwanted signal and to get the desired one.
For every design, there are some limitations, and for intelligent reflecting surfaces, we found that it would cost a lot of money to supply an entire city with reflecting surfaces. Also, it would be very hard to supply it with power because it would be attached to the walls of some high buildings. And based on our analysis and assumptions, the receiver and transmitter should be stationary. Finally, because reflecting surfaces consist of digital parts, the high temperature caused by the sun could damage it or cause some noise which may affect the transmitted signal.